Good morning. My name is Randeep Kaur, and it is my pleasure to welcome you to the inaugural session of the MHS Talent Insights webinar titled AI and Talent Management, Exploring the AEIOU and Why with Mike Sparling, MHS COO and CTO. Over the past few months, we've carefully curated content that addresses the evolving needs of today's workforce and resonates with forward-thinking leaders like you. In the coming weeks, the MHS Talent Insight Series will provide you with a unique opportunity to gain actionable insights from cutting-edge research and real-world case studies, demonstrating the tangible ROI of assessments throughout the employee lifecycle. We are thrilled to have you all here with us today. For those of you joining for the first time, welcome. We would like to begin by telling you a little bit about MHS. For over 40 years, MHS has provided trusted, data-driven solutions across our core disciplines. Our MHS solutions help to drive success in professional settings. We understand the elements of effective leadership and the requirements for an effective workplace. With our capabilities and tool sets, we help professionals such as yourselves identify and cultivate talent. Now, without further ado, it is my great pleasure to introduce you to our presenter today. With a career in business and academia that has spanned countries, platforms, companies, and minds, Mike Sparling has consistently created business value from research, data, analysis, and innovation. Mike is the COO and CTO for MHS. His present research focuses on agent goal setting based on business plan priorities. As we begin our presentation, I again would like to quickly remind you that there will be a survey sent to you in order to satisfy your professional development credit requirements. If you do not receive this before the end of the session, just send us an email at marketing@mhs.com. Now, let's start the webinar.
Well, good morning, good afternoon, and good evening, depending on where you are in this amazing world that we live in. I'd like to thank Randeep for that warm introduction, and I'd like to thank you for being here, sharing with me the world of artificial intelligence. I'm Mike Sparling, Chief Operating Officer and Chief Technology Officer for Multi-Health Systems, and we're about to go on an adventure into the exciting world of artificial intelligence. Before I do that, though, I really want to say thank you. Thank you to each of you for being partners, for being thought leaders, for being collaborators, and for being customers. Without you, we would not be where we are, and that's something that I very much appreciate. Thank you for your business and for your attention in this session. I've been at MHS since 2018, and a few months into my tenure with MHS, we hosted the last time that we were able to be together in the same space. In an act of what I will call planning genius, the hotel rooms were booked overlooking a space called Jurassic Park, which was outside of the Toronto's main arena, where the Toronto Raptors went on to win the NBA President's Championship. It was very exciting to be speaking during the day at this talent summit and then going and seeing the crowds and all of the activities at night through that championship run. Toronto hasn't been able to duplicate that since, but we were unable to actually book this meeting this week because Taylor Swift is in town for the next 2 weeks, proving once again that prediction is very difficult, especially when it's about the future, as Danish physicist Niels Bohr once said. If you were part of the audience back in 2018, some of my peers and I presented an entire presentation based on prediction and the future, and we used a theme of a fortune teller who was able to give us a fortune that we tied together into an overall package. I didn't want to repeat that today. Instead, I wanted to go back to the 1970s, early 1980s. To an age of rumpus rooms, to an age of big screen TVs that were giant consoles, and to a time very formative to me, which was when Schoolhouse Rock was on the TV. Schoolhouse Rock, if you don't know, it's having recently celebrated its 50th anniversary, was a series of cartoon episodes. I think they did about 70 or 80 of them total, that taught everything from how government worked to how language worked to how science and mathematics worked. And it was very inspirational to a young Mike Sparling as I grew up. One episode that really stood out as I was thinking through how we were going to go about framing the exciting world of artificial intelligence and talent management together was an episode called The Vowel Show. In The Vowel Show, they used a fabulous little song that I'm not going to sing for you, but it focused on AEIOU and sometimes Y. And it brought together why vowels were different than consonants and how the whole system worked and the pieces there. It imprinted, and as I was thinking of how were we going to put together this conversation today, AEIOU and a whole lot of Y really stood out. And the way that that stands out is as we think forward, I'm going to take apart AEIOU and use them as placeholders in our presentation today. We're going to start with the exciting world of artificial intelligence. Something that, as I'll present over the next few slides, seemingly came out of nowhere in the last few years, but has actually been a fundamental part of computer science since the 1950s, and in fact in neuroscience and information sciences for a lot longer before that. But I always like to start these presentations by highlighting the fact that AI is not magic. As magical as that first time that you said to Siri a question and Siri responded, or an action to your Amazon Alexa that then resulted in a package arriving at your doorstep, it seems magical. It seems what we can do is beyond understanding. But fundamentally, AI is math. I'm not going to ask you to go deep down the math rabbit hole with me. We'll touch on math a little bit in a few slides. But at the basics of it all, there is a consistent series of mathematical equations that make machines seem intelligent. And we will come back to that key point. Are they intelligent? Will they be intelligent? Or do they just seem intelligent later in the presentation? So seemingly overnight, AI got very real. I like to pivot into a couple of examples. Take it back to 2023, ChatGPT launched, and almost overnight, 100 million people suddenly had a chat window. We're engaging with artificial intelligence. We're generating results. We're discovering this brand new term when it applies to computer science called hallucination. People trying to sort out why when they ask ChatGPT for an output, it's not the same as going to a search engine and looking for a result. That the difference between factual search and generation are very, very different things. And we'll cover that a little bit later on in the presentation. But GPT set us up. But for me, this moment where AI got very real, I've spent my entire 30+ year career in the field of artificial intelligence. It's been called many different things, but it's consistently been building intelligent solutions using data and computer processing in order to achieve results. But things really became real for me back in September. I arrived in San Francisco and I was riding an Uber from the airport downtown. This was the Salesforce Dreamforce conference. There were 50,000 people converged around the conference center in downtown San Francisco. I was rolling in about 10 a.m. on the day before, and I looked over and realized that the car next to me was an autonomous Waymo vehicle. It's not unusual in San Francisco to see autonomous vehicles driving on the road, but always before, there was a safety engineer at the driving wheel. There was often a process engineer in the passenger seat, and they were working the system to behave correctly in traffic. This Waymo was different. A month and a half ago, this Waymo was fully autonomous, driving through downtown San Francisco during the morning, shortly after rush hour. I immediately downloaded the app and said, I have to figure out what's going on. And it said that 3 weeks prior, they had granted full 24-hour-a-day access to the Waymo Level 4 autonomous vehicles to transit San Francisco. That was the last Uber I took until I went out to the airport 4 days later, because I had to ride in an autonomous vehicle each time that I went out. And with each ride, I got more and more convinced that we truly were sitting at a juxtaposition between what would happen And what was happening? The vehicles had a bit of attitude. They push into traffic. They find their way to the endpoints. They drive like anyone else on the road, except you sit in the back seat and you look and realize there is no one in the front seat as the steering wheel turns and the car navigates. And it took about 2 rides in this Waymo system to realize a couple things. First, there were about 400 of them navigating the streets of San Francisco. So everywhere you looked, you were seeing Waymos, and they were everywhere. The other was, it doesn't take long for it to become a traditional action for you, that you become very comfortable in the vehicle, comfortable in the fact that an AI is driving you about the city, and you start doing other work in a very autonomous way. You separate yourself from what's happening and return back to what you can do with that time in your life. And as I took an Uber back to the airport, because the one thing that the Waymos are geo-fenced in the downtown San Francisco core, as I took an Uber back to the airport, I really, really honed in on the fact that things were changing, and they were changing fast. And yet, as much as it seems like this is an overnight sensation, go all the way back to the 1950s. Alan Turing, one of the godfathers of thinking through machine intelligence, published a seminal paper saying, I propose to consider the question, can a machine think? Alan Turing set us off on a journey, both there and prior, to finding ourselves thinking about how do and can machines think. So what is artificial intelligence? This is one of those grossly overloaded terms. Everyone has a definition. Every definition seems different. It's very easy to lose sight of where we've come from and where we're going. But if you think back to Alan Turing in 1950, establishing the principles of artificial intelligence, and the people who followed after Alan Turing, we need to ground ourselves in a definition. And I like this one from the National Institute of Standards and Technologies in the US, saying that artificial intelligence is any data processing system that performs functionality normally associated with human intelligence. And that definition really works for me because it talks about a data processing system. It doesn't talk about a computer. It doesn't talk about generative AI. It doesn't say LLM. It doesn't throw other things at us. It says a data processing system that exhibits what we would consider human intelligence in its action. And while I would never go so far as to say, for all of us from the testing industry and people who have used paper tests in the past, those great big stacks of paper where you wrote on the front page, and through brilliant engineering of secondary pages and carbon paper and masked printing, you were able to draw out from the input into the system a predictive output or outcome prediction that came as a result of the test, saying that these particular inputs suggest that this might be a possible outcome. In fact, those paper tests at the time really did exhibit human level intelligence. They guided us with some aid through a process, exhibiting intelligence as it goes. As I said, I'm not going to suggest that this is truly artificial intelligence, and it certainly doesn't stand up to the world we're in today, but it highlights a really important fact. I alluded earlier to Siri. I alluded earlier to the Alexa on your Amazon device. And it comes back to this principle, which is the second quote on the slide, which says that as soon as something works, no one calls it AI anymore. And so the first time that you use Siri or Alexa, you think, wow, this is amazing. The 400th time that you use Siri or Alexa, it's just a feature of your phone. But in making those systems work, an amazing amount of engineering, a huge amount of data science has gone in to bringing forward an interface that seems very familiar, very easy to accept, and something that we often don't remember as AI. And yet we can see it everywhere we look. My iPhone probably has 400 or 500 different AI subsystems working in it at any given time. My iPhone is no different than yours. This is where we are today. And the future will only be many, many more AI subsystems working for us and on our behalf. If we go back in time, we've really seen 3 eras of artificial intelligence. We began in the symbolic artificial intelligence era. This was the age of if, then, else, and outcomes that were very easy to define in a straight Boolean fashion. It didn't necessarily mean that someone wrote the rules, although an awful lot of early chess and checkers and tic-tac-toe playing artificial intelligence systems, even early knowledge management systems, were based on symbolic logic implemented as AI. They may have been trained, they may have been hand-coded, and even today in that Waymo vehicle, there were a significant number of symbolic AI subsystems at work to make my journey through San Francisco successful, safe, and profitable for the Waymo Corporation. But it turns out that the world really isn't binary, that things that we can express in straightforward if-then outcomes doesn't really fit the gray world that we live in. Things are fuzzy, things are not quite as simple as this, then that. And so we evolved into an era of probabilistic AI. This was really driven by a couple of factors. We got access to a lot more data, and we got access to a lot more compute capacity. And the field of statistics came forward and brought probabilistic reasoning to us, and AI evolved into more of a predictive outcome model rather than a symbolic outcome model. Probabilistic AI led for a very long time, and in fact, many of the things that we do today are based on probabilistic AI. Now, what has happened over the last, say, 10 to 12 years has been this opportunity to really shift into learning AI, where instead of us creating algorithms or doing rudimentary training to arrive at the algorithm or outcome that we're following, we've been able to feed vast amounts of data into ever bigger computers and allow the computers to follow pattern recognition and statistical prediction in order to produce outcomes that we were unaware of or unable to see. And across this spectrum, all of our modern AI systems fit. Now, you can quibble where various pieces fit and where different things occur, and some of the dates and times may be open to some interpretation, but fundamentally, we've gone through these three eras. But in my teaching career, I've often gone back and said to people, it's great to be current, but it's very important to learn from the past. And that's something that we have to continue to carry forward as we go through AI adoption processes. We have to remember where we came from, what were the lessons learned, what did and didn't work, so that we don't continue to introduce bias or negative outcomes or other problems into the systems that we build and develop. But learning AI really is where the world is at today, and it's where the real innovations are beginning to happen. So when we talk about learning AI, neural networks, and pieces such as that, what are we really talking about? Well, learning AI goes far before computer technology. In fact, learning AI goes back to the earlier works that have gone on all the way back to the era of the Greeks and the Romans and other philosophical analysis periods. But we've been thinking about how do we learn, how do we think, and we've been building models over time in order to understand that. And at the sort of nub of what we're doing today is this principle called the artificial neuron. And so the artificial neuron behaves like a neuron in a brain. It's structured in the same way. It takes input, it weights input differently, processes a function against it, and produces an output. The artificial neuron is joined with other artificial neurons in a synaptic model. And so much like our brains, 1, 2, 3, 4 neurons are joined together. The outputs of a layer of neurons become the inputs into a next layer, and we build out neural networks or relational networks of neurons that behave like an intelligence reasoning system, aka our brains. But there's a whole lot of things behind all of that, and I've put up a few lists here. The slides will be shared later. You know, you don't necessarily have to go back to 1936 or 1952, and yet going back and reviewing some of these seminal papers help us to understand where we are today and where we're headed. But it really, in the learning era, goes back to the artificial neuron and the neural network structure. But what are we able to do with that? And what are some turning points on the road down that journey? Well, I've highlighted two here. For reasons that maybe are evident or not evident, chess tends to feature prominently in the history of artificial intelligence. And so in 1997, IBM Deep Blue, which was a large computer system built principally around the ideas of symbolic and probabilistic AI, built by 30 or more named researchers, several grandmasters who spent 6 years or longer building out the IBM Deep Blue computer. This computer was then able to beat the reigning global chess champion, the grandmaster at chess. And it went on to defeat many champions and others through its application of what people would sometimes call brute force AI. Deep Blue was able to take from its programming, from its symbolic and probabilistic development background, from the work of 30 or more people over 6 years, it built a database or a view of how chess worked and what all of the historic games in chess that had been played that were available to it, to then look for pattern matches. So at this point in the game, if I match this board combination, the next logical move to make was something. And so Deep Blue would reason over this very large database of possible moves and find the next sensible move for it to make. But what was found was, well, it made very smart decisions. It made decisions that mirrored its source data, which was a whole bunch of games played by humans against other humans. And so Deep Blue is characterized as behaving very much like a human opponent in the way that it applied chess strategy to the outcomes. A very, very impressive solution, but one that only 20 years later was completely eclipsed by Google DeepMind's AlphaZero. So here was a system in the early days of reinforcement learning, a type of learning AI working on very large systems. And what DeepMind did was it said, well, we're not going to teach AlphaZero by looking at all of the games that have been played. We're going to teach AlphaZero the fundamentals of how to play chess, the simple move structure that governs the board. And then we're going to turn DeepMind, or we're going to turn AlphaZero loose on thousands of CPUs, or in this case, what are called tensor processing units, which is a type of AI processing unit. We're going to turn AlphaZero loose with 5,000 of these processors to simply play chess against itself based on the rules of chess. And it went through hundreds and hundreds of millions of games that it synthesized until it arrived at what it believed were the right strategies or the methods to play chess. And AlphaZero learned all that in days, not years, led by a team of 17 researchers, not 30. And it took compute power and turned that into outcome. AlphaZero, in the end, was undefeated. AlphaZero was able to own the chess world in a few days of training. Evidence that reinforcement learning, that using learning systems would be the future of AI. Google DeepMind published the results of AlphaZero and then went on to do a system called AlphaGo, which Go was believed to be a game that AI would never be able to achieve or win at. And yet, Go was toppled in an even faster time frame than chess was by this architecture. It is an amazing piece of work to see this evolution over 20 years. And I'm just going to highlight the fact, I said there'd be a little bit of math. I'm just going to highlight the change over 20 years in how much technology was available. That IBM Deep Blue was able to work at 1 trillion operations per second, 1 teraflop of compute resource. And 20 years later, DeepMind AlphaZero worked at 92 teraflops. So it had about a 92 times advantage in compute power in order to generate out its approach to chess. But what that advancement meant was that instead of taking 6 years to develop, AlphaZero was able to do that in 4 days. And when you start to extrapolate out, as computers get more and more powerful, as we'll see in the next slide, as time to outcome reduces, this embedding and generation of intelligence will only get faster and more capable and more powerful as we go forward. So let's move ahead to 2023, the release of ChatGPT-4. GPT-4 stormed the market. Suddenly everyone had a window into it. Everyone was using it. People were generating things. Students were handing in homework assignments that said, sure, I'd be happy to generate something for you, and then followed a homework assignment that should have been edited and managed. That a lawyer in Los Angeles submitted a court briefing that turned out to be referencing and citing case law that was actually episodes of LA Law. And many other examples of where GPT took people who had never worked with AI, had never thought about human in the loop, or had never thought to question the validity of the results that were achieved, and it made this a mainstream feature that we had to learn through. GPT stands out for a few reasons. There aren't that many published stats on GPT-4, but what has been inferred is that it trained on 21 billion petaflops. 1 petaflop of computing power is 1,000 teraflops. Remember that AlphaZero trained on 97 teraflops. And so this is many, many orders of magnitude more powerful computing environment. Trained for several months, and that's why GPT, both the compute power and the time that it reasoned over a very large corpus of information, it was able to become more intelligent at what it does, translate and generate between source to output. AlphaZero had 800,000 neurons and 8 billion synaptic connections. Say that fast at a cocktail party. GPT-4 is estimated to have 10 million neurons and 1 trillion synapses. And look at what it does. Just to sort of put that into perspective, you and I are estimated to have about 85 billion neurons in our minds and 600 trillion synaptic connections between our neurons. So the question becomes, will we get intelligent machines by finding ever more powerful computers to mirror that structure? Will we find a different solution to replicate what we're capable of doing? Or are machines really thinking? Or are machines doing something very different? So the question becomes, does AI currently think? Can it ever think? This is something that can be discussed at length over a pint of beer or in a social setting. I like to go back to a position that John Searle took in 1980. Published an article that talked about Searle's Chinese room. He posited this hypothesis that said, imagine a closed room. There's a window on the side into which someone can pass a document that has Chinese symbols written on it. Could be any language, could be any way that we're expressing input, but stick with Chinese for a minute. Searle said that inside that room, there was a person who had a rule book not unlike what IBM built with DeepMind. A rule book maybe not dissimilar to what was found in AlphaZero or AlphaGo in order to learn the rules of chess. But that complete rule book lets Searle, the person inside the room, take each character and translate it into another language. That rule says, if this character, write this result. That rule further is complete, and it says, and look backwards and see if these references have been made and modify the prior content based on the character that we're currently looking at. And when Searle, the person in the room, completes the translation based on the rules from the input characters to the result, they pass it out the output window to someone on the other side who reads it and believes that they are fully understanding the translation of that material. Now, the question that was posited by John Searle, was, if that works, which it does, is there actually knowledge at work, or is there thinking at work? Does the person in the room understand what transpired, or are they very rapidly executing rules and doing pattern matching? It's well beyond the scope of the conversation that we're able to have today, but it really is at the fundamental level of, will humanity reach this vaunted principle of artificial general intelligence, a machine as smart or smarter than human, or will we forever create ever more powerful smart functions while retaining the creativity and thought leadership that is, credit of the organic mind, but not really currently replicatable in the silicon? It's a very, very interesting thing to sit and think through. And it's something that I'll leave with you possibly for the question and answer session later, or for another venue to really go deeper into. So I want to take a second now and pivot into the other part of our conversation as we start thinking about how AI comes into the talent market, the world that all of us work in, the place that you're most comfortable thinking through. I want to talk a little bit about a brand new evolving field called artificial emotional intelligence. I highlight this little quote on the right-hand side from some conversations that we've had with Meta AI researchers and engineers who really highlighted that already very early into the Meta AI agents deployed across different technologies that they offer out, up to 30% of conversations already are topics of personal concern and mental health. And so key to how these AI agents are being built, trained, and deployed is understanding emotional intelligence and how it applies into artificial intelligence. So we're very familiar with the classic emotional intelligence models. This model drives our AEIOU product. It's guiding, as Jenny alluded to on Tuesday last week, the work that she and her research team are doing around the future version of EQI. It drives a lot of the different products that we put out. It works very well for human to human, but how does it work for human to artificial intelligence or collaborator to agent? And what's the applications that we can take in the talent world and bring that forward? Well, it turns out that there's a lot of research going on right now, that MHS is participating in some of this research, that things that our former CEO Hazel Weldon and I have discussed within our test publishing industry as far back as 2018 is the role of understanding human emotional intelligence and other characteristics and understanding machine intelligence and the characteristics there. And really thinking about that Venn intersection between the collaborator, a person, and an AI system, the agent, and how do they interact with one another. And so emotional intelligence brings into the AI world the need for the AI, so the agent on the right, to understand a lot of things. Needs to understand the intent of the request. So I've processed a request and I've asked for some result, but really what is the intent of that request below the basic syntax of the request? I need to have an affinity with the collaborator. If I as the agent have never worked with the person engaging with me, if I have no memory of our past interactions, I have to assume an awful lot that maybe later a newer agent that has longer term memory is able to remember. It can remember that my preference is for black coffee. And if I ask the agent, where is the closest place I can get coffee? It won't steer me to a tea shop. It will steer me to a coffee shop where someone may have made a rating reference once about the quality of the black coffee, not the quality of the different types of milk products that are available or something like that. That affinity and long-term memory are going to be very important to the agent understanding the collaborator and engaging with them in a way that demonstrates elements of emotional intelligence. And we have to understand the collaborator's identity and how they choose to present themselves to the AI. And on the left-hand side, the collaborator, what we found in some early work and some conversations and some things that we will be championing over the next little while is that a lot of the assessments in our portfolio today really help with understanding how an individual can be successful engaging with an AI agent. It's not teaching the AI how to do assessments. It's using assessment, the things that you do so well in your coaching and your talent development world. It's using assessment to help individuals understand how they can engage with an artificial intelligent agent to produce more meaningful outcomes. It's a very exciting field to be working in. It's rich with both opportunities for us to get it very right and opportunities for us to get it very wrong. And it's really good to see leading AI publishers like OpenAI and Microsoft and Meta and many others bringing these principles in and being very concerned about how the guardrails and privacy monitors are going to have to work at that point of engagement, on how we ensure that the models understand not just the semantics of the request, but also the meaning behind it and the long-term memory that will come into play so that the responses are tailored correctly and guide people to the outcomes that they're expecting. much more in a future session, taking apart that stack on the left-hand side and really talking about how assessment can help individuals prepare for a world where co-pilots and agents are the products that we work with as much as our peers, our collaborators, our bosses, and our employees. If there is one thing that you could take away from this conversation today, it is how passionate I am and how passionate MHS is for this space alone, and the opportunities that will come from the application of what we have a 40+ year history with you of bringing to market, and pivoting that into an entirely new field, opening up brand new opportunities for us to go to market together, and helping to create a world where agents and collaborators engage in meaningful outcomes and ways that are very positive. And so as we begin to come to the close on this particular talk, I really want to look at some of the opportunities and the uncertainties. I've filled out the AEIOU, and I hope I've given you a lot of whys as we've come along. But really, where do we go and look for opportunities? Where do we look for risks? And what do we do to navigate through this world so that we are all creating AI-infused individuals, not AI-confused individuals? Well, as I alluded to before, this is nothing new for MHS. This is nothing new for those of us in the test publishing industry, and this is nothing new for these types of conversations that we've been engaged in. I go back to 2018 when I first came into MHS. Hazel Weldon, our CEO at the time, she and I did a presentation in Athens, Greece, at the European ATP, the Test Publishers Conference, where we really honed in, even back then, 2018, on bias, transparency, ethics, and AI. And that led to our trust framework. It led to a lot of the work that we do in how we approach the use of AI and generation and insight and learning in our product development and our products that we deliver to you. And this particular seminar and all of the ones that we did going forward and all the ones we will do going forward ensure that we're constantly sharing and aligning ourselves around those core principles of our trust framework. And it's very exciting now with John Clark at the helm as our new CEO. John actively picked up the trust framework and personalized it and brought it into a new age, an age where learning AI drives so much more of our outcomes. And so watch our mhs.com/trust site to grow more with more of a focus on learning AI and how we build trust, not only between ourselves and between our customers, but between ourselves and our collaborators that aren't humans, but are actually AIs going forward. Because agents and co-pilots are going to be fundamental parts of our future going forward. But how we engage as collaborators with agents, how those agents engage with us, and how they act and perform actions that we direct or review or authorize, that's really going to determine how the perceived value of that work will take place. We truly live in an amazing time. We are in the fourth industrial revolution, a revolution driven by data, by compute, by access to energy, by collaboration, and by outcome. The World Economic Forum introduced the idea of the fourth industrial revolution back in the late past decade, and it really has held true. But we need to think about assessment in the fourth industrial revolution and really come to understand the effect that AI, network, data, and processing have on assessments. That knowledge and expertise have become commodities, that we are bringing a lot of what used to be stand-apart expertise and making it a feature of the network. It's becoming something that anyone can access. And so value is added to knowledge and expertise, as opposed to knowledge and expertise are isolated capabilities that can be brought to a problem. That the sources and fidelity of data are only multiplying. That the amount of data we generate across the globe on a daily basis exceeds what used to be generated in decades or centuries before. And that's only accelerating as smarter devices produce more intelligent data and make it available for more training, analytic, and learning from. The velocity of feedback loops is accelerating, and so we're getting answers faster. If you think back to DeepMind taking 6 years with 30+ people, to AlphaZero taking 4 days with 17 named researchers, and you begin to see how fast things are happening. That now people can sit and spin an entire company up based on generative AI in an afternoon in a coffee shop. You can use a cloud host and you can be in market before you're finished your second double latte. That is a world of accelerated activity. Intelligence at every node of the network is taking place as we are living it out right now. That each of those Waymos I wrote in, that each of us with a smart device on our wrist or an intelligent smartphone in our pockets, we have compute power that has never before been seen at the edge of the network. And there's a very, very interesting point that will come up in a future conversation I hope we're able to have, which is, do we want a centralized AI future, or do we want a decentralized AI future? Do we want to push our intelligence closer to us, or do we want to consolidate our data and process closer to large enterprises in big data centers at the edge or at the other end of a network connection versus the edge of the network where all of our personal devices operate? I personally tend to view the world as evolving to one that's sometimes called BYO AI, or bring your own AI, where each of us will have a personally trained and honed AI or network of AI agents that work on our behalf, and those will synthesize into the environment as opposed to be features of someone else's environment. But I could be very wrong on that perspective, and we will see how this unfolds over the next 5 to 10 years with a lot of different impacts that we're all going to experience and be a part of shaping. And always there's this consistent downward pressure on price and cost. And so understanding how to implement an AI system today really requires us to think about what the cost of that activity is. And yet, in only a few short months, it took about 12 months for the price of one inference from a GPT engine to drop by 97%. Well, if you in 2023, in March or April, had built your business model around the cost of a single generative response based on a prompt, and you built your business around that, a little over 12 months later, 97% of your cost has now been removed, and you're executing at 3% of the cost that you did a year earlier. And that will just continue to get smarter, faster, and cheaper. And we have to figure out what we want to do with all of that power and where we go with it. And one of the really big things that we'll do with it is we will begin to take different kinds of input into the reasoning models that drive our assessments. And so we've done for a very long time Likert scales or sometimes performance measures, and we've gathered data in fairly static and consistent ways. But we're giving way now into understanding bio and neural markers as other sources of input into the reasoning cycle that an assessment provides. That an Aura Gen 4 smart ring, of which I don't have one, but there's a picture on the screen, there's 18 sensors packed into that ring. There are 24 predictive values that come from that ring, and there are 2 biofeedback actuators that the system is able to provide feedback to the ring wearer through. Well, this is really nothing new to MHS. We've worked with a company called Revibe. In fact, we're an investor in Revibe for about 3 or 4 years now. That was an early version of a smartwatch for attention deficit. And we took one of our assessments, the Connors assessment, and we brought that into a smartwatch that carried 2 sensors, 3 to 5 predictive outcomes it was able to generate, and 1 biofeedback actuator. And that company has become a leader in helping children manage, through a smartwatch, attention to task and outcome. And how did we do that? Well, I mentioned in our SLT welcome last Tuesday that we had built this new generative platform, or a new platform that we hosted our assessments on, called Janus. And if you were in that session, or you've heard us use the term Janus before, this big white model in the upper right corner of the slide is our Janus reference model. And we anticipated in the Janus reference model that we would have multiple sources of observation items, multiple sources of input. It was going to move beyond Likert scales, was going to move beyond classic performance measures, and that we would gather bio and neural marker data through many different channels, many different spaces, that would all go into our predictive analytic models, which are our evaluators, that arrive at those outcomes that we believe that we've sensed or seen through the data gathering cycle, and providing that into the classic enrichments, the reports that we produce, or more recently through some of our work in apps and other deployment cycles, providing that evaluative, that predictive output in as triggers into workflows in other platforms. And when you start to see those predictive outcomes lighting up new workflows and creating action immediately that begin to change the pace of the value that that assessment produces, that's when the real value of this world that we're in comes to life and goes to work. The choice is really ours, to lead or to follow. The quote on the left is from the Prime Minister of Canada back in 2018, but really highlights the fact that the pace of change at no matter what point you stand has never been as fast as it is at that point, but it will never again be as slow as it is at that point. Things will only get faster from here. Things will accelerate into change for us. The people who adapt to change, the people who have strong emotional intelligence, who have good adaptive change management styles, who understand their personality and their outcome, will be able to lean into this world more than others. And that's really the opportunity I see for us today in the talent space, to bring AI, to bring the transformations that are happening everywhere, to really create value for our customers by finding where the world is headed, not where the world has been. Things will never again be this slow, even when we think it has never been this fast before. And really the great risk that we face is people are living the Jetson life at home, and they come to work, they come to the places that they engage with us, and it feels like the Flintstones in so many different places. So my challenge to you today is using assessment, using artificial intelligence, using outcomes and other means, help the world of the future, not cling to the world of the past. And with that, I'm going to hand things back to Randeep in order to take questions and for the survey. I'd like to thank you for your time today. I'd like to point out that my 16-year-old daughter looked at this slide when I was rehearsing and said, "Dad, that's a very cringe-worthy image. Looks like you just learned how to use DALL-E." And I felt very ashamed by that, but thought I would leave it in here. Thank you for your time today. Thank you for your partnership, and thank you for the opportunity. Independently and together, we're able to create. It is a beautiful world ahead of us, and it's one that AEIOU and sometimes Y can really help us understand. Have a great rest of the Talent Summit.
All right, let's dive into that first question from our audience. Mike, this one is, how can AI help in identifying and nurturing high potential employees?
I think that the real answer here, and maybe the point that I was trying to bring home throughout the whole presentation, is that the classic assessment life cycle is being disrupted by artificial intelligence, and how we approach talent management, talent development, and just nurturing skills and ability are all changing based on the availability of AI. There was a line in a presentation a while ago. We were looking at a particular generative AI product in the assessment field, and the party presenting, said this point that really stuck with me, which was that the age of one and done assessment is all over. And if you think back to sort of the opportunity that ever more advanced sensor technology gives us, whether those sensors are smart rings or integrated into our working systems or the platforms that we engage with customers on, we're getting more and more data. And that data is able to be reasoned over, that our assessments are able to then be run more often, and that the outcomes that come from that are able to influence or coach us, nudge us, coach us, or bring us to new outcomes or training, so that we continuously improve. And that investment in talent development, in high potential individual development, switches in that case from being a point in time that happens occasionally to a continuous improvement cycle. And I think that continuous improvement cycle is that Venn diagram intersection point where The collaborator and the agent are able to synthesize together and create new outcomes continuously through improvement and learning. And that's going to change how we manage workforce. That's going to change how we promote and guide to new outcomes. And it's for sure going to change how we do assessment across the talent spectrum.
Thank you, Mike. We have another one, which is, what are the ethical considerations when using AI in talent management?
It's a great question. I think that we have to operate, and you'll see on our mhs.com/trust site and all of the material that we've published and focused on managing ethics, managing bias, and being prepared for the systems that are implemented and performing is a really important responsibility that we have to undertake. We as MHS have said for a very long time, the human in the loop is a critical factor in the implementation of AI systems, and transparency is the other side to that. Human in the loop means that for any decision that's going to be taken, any action that is going to be recommended, a person is reviewing and approving that action. Now, things are starting to change a little bit. We talk about autonomous agents. I rode in a car in San Francisco that was making decisions on my behalf without a human in the loop. But if you step back to the control framework, the principles of human in the loop and governance are taking place in all of those different decisions. That transparency is crucial, that being aware of when AI is being used, when predictive decisions are being made, when recommendations are being taken, that transparency and traceability have to be evident and front and center in the work that's taking place. Bias is a real risk, and finding the ways to ensure that we are ethical in the actions that we take is really a responsibility of each of us. Machines will never understand, in my opinion, ethics. Machines will never understand bias because they are operating algorithmically based on what we've developed within them. So it really is that collaborator side of the equation that has to be the force that brings ethical reasoning, looks for bias and eliminates it from the systems, and ensures that the principles of transparency, ethical, and bias reduction are always at force in the decisions and actions that are being taken by AI systems.
Thanks, Mike. One more. Can assessment systems detect the use of AI by candidates when completing assessments?
Well, that's a very good question. Can an AI detect the use of an AI? There's a lot of work that goes into that. Certainly, that's a field, across all spaces. Can you detect when an image has been generated by AI? Can you tell when prose has been generated? I think the question that we really have to ask is, what's the advantage to the individual to using AI, in particular in a talent assessment? And what's the work that our research scientists, my associate Jenny Pitkin last week in our SLT framing for this entire Talent Unleashed session, all of the different research scientists that work for her, all of the authors that we publish on behalf of, everybody is working to find those ways to detect when invalid input, or to detect when a potential machine is being used or an advantage is being created that isn't in the spirit of the assessment that's being taken. I really think that the true change is going to come when we rely less on polling for answers or input and more on being integrated into the workflows and the transactions, because it's much harder to mask or impersonate a neuro or a biomarker than it is to, from off screen, receive an input and type it into a question that's being asked. And so increasingly, our research scientists are looking at the ways that we do deeper integration as opposed to question and answer, and that change in how we do data gathering, that how we gather the observation input that goes into the assessment system, that's going to be driven more by things that are much harder for other participants to be part of that they'll really be bound to the individual taking that assessment. I think there are some other sessions through the entire program that we're running this month that are touching on some of the early work that represents that. And certainly there'll be more work that MHS will publish through our blog systems, and our research scientists will take to conferences in order to further that. Hope that answers that question, Randeep.
Yes, thank you again for a very engaging session today. And everyone, thank you for joining. And I wish you all a very nice rest of your day.